Hi team, it's good to be back on the airways. Today we're going to have a look at, carrying on from our work from hyperbolas, look at the truncus. So the truncus follows the general rule of y equals 1 over x squared, or y equals x raised to the negative 2, where the negative in the index simply means 1 over. So this is actually the same for hyperbolas. Hyperbolas can also be written as y is equal to x to the negative 1. So to start off this one, I just want you to go through, and for the rule y equals 1 over x squared, the truncus, I want you to fill out this table of values here. I'll give you a moment to do that. Just pause the video. Okay, so let's go through it together. So 1 over x squared, when x equals negative 4, is 1 over. Negative 4 squared is positive 16. Negative 3 squared is 1 over 9. Negative 2 squared, 1 over 4. 1. Now negative a half squared, so that's 1 over. Negative a half squared is 1 quarter, which is equal to 4. So we can see as the negative fractions come in, y values actually gets exponentially bigger. When x is equal to 0, 1 over 0 squared, that's undefined. And then you'll see when x is equal to a half, we've got positive values again. That's 1 over a quarter, which is equal to 4. Then 1 is 1, a quarter, a ninth, and a 16th. So we can see, much like a parabola, that the truncus is symmetrical about the y, or the y-axis. Okay, so if we're going to draw that out, as x gets smaller, negative smaller, y goes off to 0, you can see here, and as x gets negative larger, or goes off to negative infinity, y gets smaller. As x goes towards 0, as a fraction, y gets exponentially bigger, and the same on the other side there. So we've got a symmetrical graph with asymptotes once again on the y-axis and the x-axis, because y can never equal 0 with x in the denominator, and x can also obviously never equal 0 there. Okay, now I want you to try and have a go at graphing y is equal to negative x raised to the power of negative 2, or 1 over negative x squared. So if we're going to draw that, so that's also negative 1 over x squared. So try and draw this in graph. So pause again, have a go. Alright, so with a negative x squared, all it does is flip it down into the negative part of the y-axis. So once again, still symmetrical. If you put it in the table of values, you can see that it will just flip it down over here. So that's when there's a negative truncus. So copying this in, make sure you've got a full set of notes here, guys. So that's what it'll look like there. And now finally, just looking at transformations, or translations, sorry. So what moves, so just put a heading in your book, translations. And when you've got, much similar to the hyperbola, when you've got a form y equals a over x minus h squared plus k, the asymptotes will be x is equal to h, and that should be x is equal to k, not x is equal to, sorry. Once again, that's y is equal to k, and x is equal to h. Apologise for that, guys. There's been a mistake there. That's why you always got to check your working. So y is equal to k, x is equal to h means that the denominator cannot be equal to 0. So let's have a look at an example together, guys. Y is equal to negative 1 over x plus 2 squared plus 1. I want you to see if you can find the asymptotes yourself. I might just start a new video so we can go through this example together. So once again, just like a hyperbola, what you do is first, number 1, find the asymptotes. Then 2, find intercepts if they exist. And then 3 would be to graph. Let's have a look at this in the next video, guys.